Okay. For boundary value problem, we have some function y and x, and we have some initial x0 and some final x final. For boundary value problem on the left, we have some boundary condition 1, say it's y of x0. On the right, we have another boundary condition 2, say we have y of x final. So in order to get this from left to right, we will guess some initial y prime of 0, x0, with some a, and then we'll see where it lands up. And then we'll calculate the error, say, define it as E is equal to y of the IVP at the final location minus our boundary condition 2. So y of x. So this is from IVP minus the boundary condition 2. And eventually we want this term to be minimized to some numerical tolerance. Say it is around 10 to the minus 4 or minus 5. So we want it to be as close to boundary condition 2 as possible. So finally, after iterations, we'll find some optimal A star such that it ends up at the boundary condition 2. Okay, and let's look at how do we do that numerically. So for this practice problem, we have a second order ODE and we want to reduce it down to a system of first order ODE by using auxiliary variables. And then we have the typical boundary conditions, and we want to solve it with shooting method and compare it with the numerical solution by solve BVP. So the plan is to first solve it with solve BVP, so we have some ground truth, and then we can code up the shooting method to see our method with shooting method matches solve BVP. So to do that, first let's look at what solve BVP requires. So solve BVP requires first a function, which is the ODE. So to define the ODE, we use dy0 dt, or in this case dx, is equal to a lambda function, the independent variable x, and dependent variable y0, y1. And it's equal to y1. And dy1 dx is equal to a lambda function of x, y0, y1, and it's equal to 5 minus x squared minus sine of x times y1 plus cosine of x squared times y0. And we want to stitch these two as a system. So ODE system is a lambda function of independent variable x and the list of dependent variable z. And we evaluate each of the function with x star of z, and then this one also x star of z. And we can verify this system works by using some arbitrary numbers. So it gives out 2 values. So this is correct. We'll then need to define the boundary conditions. And the boundary conditions are y0, and this is 0 means this is the original function on the left. So x is equal to 0 is equal to 3. And then y1, which is this one denotes it is the first derivative on the right. So parentheses 1 is equal to 5. And in solve BVP, we want to define boundary condition as a function instead of just numbers. So it takes in y left and y right. And the first boundary condition would be y0 minus 3 is equal to 0. So that will be on the left, y of left, index 0. This index 0 means it's the original function, minus 3 is equal to 0. And this 3 will be y0 left. On the right boundary, we have y prime of 1. So that will be y right, index 1. This 1 means that it's the first derivative, minus 5, and 5 is y1 right. So when you define these, you should be able to see these are consistent. So these are the location left, and then the index here are whether it's original function or the first derivative. And then we need the x points. So we're defining it from 0 to 1. So x min is 0, x max is 1. And we didn't specify the length, but we can do 1,000 points. So let's do 1,000 points. And then we can use linspace because we already know the number of points from x minimum to x maximum with 1,000 points. And then finally, we need some initial guess. The initial guess should have the dimension of 2 rows and x length columns. The 2 rows each represents the original function and the first derivative, and the x length dimension represents the time points. Zeros. And then we can substitute everything into solve BVP. So we have the function for the system, boundary condition, the x, and the initial guess. And what we care about is the solution. So dot solve will give us a function. So we can assign this as the BVP solution, SciPy BVP solution. And then we can evaluate this at x, and this will give us 2 rows and 1,000 columns. The first row, again, is the original function, and the second row is the first derivative. And we only care about the original function, so index 0. And we can plot this with respect to x. So next dot plot, and then let's make a figure. And this is our solve BVP solution. Let's label that. Now we have established a ground truth. So this is the true solution. Now we need to code up the shooting method. How do we use shooting method to solve BVP? For shooting method, we first solve an initial value problem. So first use a solve IVP, and then we iterate by changing A. So we first establish a solve IVP. And what does solve IVP need? It needs the function, which we already defined as ODE system. It needs the t-span, which is x that we defined, and the y0, which is the initial conditions. And then for the initial conditions, we have one of our left boundary, so y0 left is one of our initial condition. But the other initial condition, we don't know. We need to guess some y prime as A. Let's first guess it as random guess 0. And then we evaluate t, so t eval is equal to x. Too many variables to unpack. Okay, let's look at x. Oh, so here the second argument t-span should be the boundaries, not x. So we should input x bounds. So we need to define x boundaries as x0 and x minus 1. So this is the initial point and the final point, which should be 0 and 1. And we should input x bounds instead of x. And that will give us the solution. And what we care about is the solution. So the solution will be y. Has 2 columns. First column is first 2 rows. The first row is the original function. Second row is the first derivative. We only care about what do we care on the right-hand side? On the right, we have the first derivative, and we want to match this. So we care about the first derivative, so index 1. So this is the first derivative. And we care about the last point, so -1, in order to get the right boundary condition. So this is our result. So y right. Okay, let's define it more generally. So this will be the ODE solution. Dot y is the ODE solution. And I can unpack it into x1 and x2. And what I care about is the last element of y1. And then we want to compare this solve IVP result with our boundary condition, which is y1 right of 5. So if we calculate the difference between them, we can assign them as the error. So the error in this case would be +3. And how do we change this A? We use root finding algorithm of not shooting method, a bisection method that we learned in lab 1. So the bisection method was used to solve a root finding problem. For example, if you have some function, you want to make it find the place of x that makes the function 0. So you have some f and x, and it has some shape. And you want to find the location at which it's 0. What is the x? You do this with bisection method. You first define a left boundary. So you have a left boundary. And you have some right boundary, at which the left boundary should have one sign. So here the sign is positive. On the right, we must have a negative. So by intermediate value theorem, if I have some positive and some negative, there must be at some point, if it's a continuous function, it meets at 0. And the bisection method says that what I can do is to find the middle point. So I make this x middle, and I evaluate this function and see if it's positive or negative. In this case, it's negative. So it must be in between a negative value and a positive value. So I'll move this bound here. So I assign x right to x middle, and then do this iteratively until I find the root. So in our context, we will need to define some A that makes the error positive. So I'll denote that as A plus. And we'll also find some A such that the error is negative. I'll denote that as A minus. So we'll have some A and some error. Some error, some A. We'll have some A at which the error is positive, so A plus. And we'll have some A such that the error is negative at here. So that the error that's around 0 should be in between these two A. In this case, I tried A is equal to 0, and we found a positive error. So I'll say this as A positive. And now the task is to find some A that's making the error negative. So I'll just try some values, -10. Okay, this is negative. So I can assign this as our initial guess of A negative. Okay, and I want to iterate the A here. So with this, these are the initial guesses. And then I want to iterate all of these by changing the A. So to iterate this, I will need a loop. So I can write a while loop. And inside the while loop, I have two conditions. First, when the iteration counter I is smaller than the maximum iteration, I'll continue this loop. And when the absolute error is bigger than the tolerance, so when the final goal hasn't been met, I will keep looping this. And so I will need to define the iteration counter. So I can define the initial iteration counter as 0. I'll set the maximum iteration as, say, 10,000 or 1,000, doesn't matter. And the error, the numerical tolerance as 10 to the minus 4th. And the error here, we will have the error calculated inside, but we need to initialize the error such that it's greater than the tolerance. So I'll just make it 2 times the tolerance so that it has been initialized. So the next step is we have defined A plus and A minus. Now we want to find the A middle and evaluate the error there. So the A middle will be just the average of A plus and A minus. So I'll define a A middle as the sum of A positive and A negative divided by 2. And my initial condition, I will substitute that as A middle. And it will solve this ODE. So after solving this ODE, I will have some error. And this error could be positive or negative. So the first, copy this. There are 2 scenarios. So if the error at A middle is positive, so let's say it's here, we want to discard the left interval because it's not guaranteed that there is a 0 in between here, but we want to keep the right boundary because it's by intermediate value theorem, it's guaranteed that it will cross the 0. So what I'll do is to assign the left boundary, so A plus, as A middle. This will be an assignment. And otherwise, if I have a scenario that the error at A middle is less than 0, so it will be like this. So here it's not guaranteed to cross 0, so we will discard this interval. But here it's guaranteed by intermediate value theorem, so I'll keep this. So I'll do this by moving this boundary here. So I'll assign A middle to A minus. And I'll code that up with code. So after having the error, I'll do bisection. So if the error is positive, I will move the A plus, so A positive, as assigned it to A middle assigned to A positive. And if the error is smaller than 0, I'll assign it to A negative. And otherwise, I'll just raise an error because there shouldn't be other options. And finally, after this iteration, I'll increase the iteration counter by 1. So plus equal 1 means that this is equivalent to I is equal to I plus 1. Okay, so I'll run this code and then it ran through with no problem. So I should look at the error first. The error is minus 10 to the 5th, minus 5th. So it's a very small error within our range. We can also verify that by printing this inside the loop so we can see each step. Print I, this will be iteration counter. Print the current A middle, and then print the error. And you'll see that as the iteration goes through, the error term, the magnitude of the error gets smaller and smaller. And then we're getting convergence to our optimum A, which is minus 2.27. So this will be our optimum A. So I'll assign it to A optimum as A middle. And after having this, we now know what is the optimum A. So we'll need to just solve this initial value problem once with this optimum A, and we'll get the solution. So I'll just copy this code here. And so instead of A middle, I want to evaluate at A optimal. And then evaluate this initial value problem, and we find the solution. And we can plot the solution, X, and because we care about the original solution, so Y0, we label it as the shooting. If we run it, this is exactly on top of sub BVP, so I can make it dash line to further illustrate that. So they're overlapping each other, meaning that the shooting method is correct. Okay, any questions on this? So the process goes as first we establish an initial guess such that the error is positive for some A and the error is negative for some A. And then we'll define the iteration parameters. So the iteration counter, maximum number of iterations, numerical tolerance, and the error. And within the loop, I'll calculate the middle A and use the middle A as the guessed initial condition, solve the initial value problem, and calculate the error. And according to the error, I'll move the boundaries using bisection method. And then with the optimum A, I solve the initial value problem the last time. And then we get the final result for shooting method. And you can try this out with the practice problem. And my caution is that if you copy and paste the code, this is super easy. You just need to change the boundary conditions and the equations. But I will suggest you to code this from ground up so that you know the underlying logic. So that when I ask you on an exam, if I have this scenario, which interval do you keep? Which do you discard? And where do you move? How do you move the boundaries? You can have solution to those. Okay, we'll come back in 20 minutes. Great question. So in lab 1, we have this F middle times F left is smaller than 0. This is to determine if there is sign change. So this will be the product of this will be a sign change indicator. So if there is sign change, that will be positive times negative. And if there's no sign change, that will be positive times positive gives positive, or negative times negative gives positive. So we're detecting if there's sign change. So that's why we're multiplying them together. So the logic, the if-else logic is the same. But what we are caring about now is not sign change. We're caring about is if the error is positive or negative, which is already embedded in the error. We don't need the multiplication of them. So if the error is positive, then I'll keep this interval. If it's negative, I'll keep this interval. And this error is already calculated with the YIVP minus boundary condition 2. So this, I think this will be replacing the multiplication in lab 1.
I'm just looking at the right thought, like someone that thought that we thought. So in x-axis there's 2 points, but I'm trying to find the right point there.
Oh, right. So your question now is, if I have 2 roots, how do we find the 2 roots, right? So for numerical method, so this is caveat for all the numerical methods. It will give one answer only. Just like the solve BVP solution, even if you have infinitely many solutions or no solution, it will give you one unique answer. So how do you get, so we have, in this case, we have two solutions, right? So how do we can find this one by giving it some left and right bounds. In order to find this one, we'll need to give it some another educated guess of left and right bound in order to constrain this. Okay, let's see. Let's see. So if you mean if I have some, here I have a negative and a positive. If I were have some a middle, and if I have here, I should keep this. Good point. So then the logic that I coded have some logic issues. So we need to find.
Because your code is based on the fact that you tested out in everything,
Yes.
then you test it in making sure you normally the fact that the opposite thing, then you code.
Right.
One of your code could just satisfy both.
Yes. Okay, difficult logic. So if this is the case, so I don't think it gives a bug because if you consider both cases, if I have the error is smaller than zero, so the error is smaller than zero here and here, right? But I have a plus on the left and a plus on the right, two cases. I will always want to keep the one that crosses zero and I want to move the a minus to the a middle. And so the final step are the same for these conditions. even though that the left and right has been changed. But we're caring about we're changing the A plus and A minus instead of the physical coordinate of left and right. I think that's one distinction with the actual roots finding problem. It's a good question. Could make an exam out of that.
Hey, what? So you're defining A positive that if the error is positive, it's not, right? The point is positive.
The
The error is
So A positive, I define it such that the error is positive. So A plus is, I should write this out more explicitly.
because it tested out.
Yep. This is an oh. So if you have give it a comma, it will be recognize it as a two. So say this. Say this is some list of 0. And so if you have a list, yeah, and then you have some arbitrary elements like 0, and then I want to index 0. So, but if I put a comma, this will be recognized as twofold with one element. Like that. So yes, correct. So that should be motion. One zero must be one. First, I don't think this relates to the code issue, but you need to multiply by the corresponding y0 1. These are just constant one. Oh, these are analytical solution. This is analytic solution, so we can compare things. So if you rewrite this into a system.
As just one, I just wrote it in here. I thought this was it.
But that shouldn't be that bad. Go to solve. For the error function. Oh. So what I'll do is to copy this part. And then test it outside the function. And see if it works. So let's say, copy this. Paste this. I'll just do it some. See what's function. Oh, so the initial condition is
Is it because there's a comment?
right. Okay,
Oh, okay. So it's just comments.
so if you have something with a comma will recognize as a tuple with one comment.
It doesn't feel like.
So the solve BVP, I think is correct. But the shooting method is kind of not correct. Let's see, your initial condition. When that's correct. Oh, yeah. So when you're calculating the error, you're calculating the original function to the right.
What did you do? Oh, okay, perfect. Thank you so much.
Yes. So the guesses are to guess outputs.
Yeah, is this just using what like something that it's fine. And so like I need to have empty guesses. How do I choose these usually?
So here you have dot and so on, right? So now this is a function. So you want it to be dot one. This is dot one. You use dot one. Double dot one. So it depends on what you need. So if you want it to be dot cancel out, it will be your function, and you can evaluate this function at some point. So what you can do is to put this function. First, let's look at what this is. This is a function. You can evaluate this function at your left boundary, which is x min. This is the original function. First, the original function is minus 2. You will satisfy with your satisfy your boundary conditions. Yes. And then you can do similar things.
So if I do and flash, you know.
It doesn't be.
So it's
So in this case, you're looking at the right boundary condition. Is it first derivative or the function?
yes. This is one.
This is the original function. So original function means y0. It's y0. So we need to change this.
So this would be zero and both, correct?
We have 0 in the original function. So 10, in this case, 10 is the original function.
For shooting method, is it using your IVP to solve BVP?
A combination of IVP and bisection method.
Okay.
Or a root finding method in general. Doesn't need to be bisection.
Investigate the first derivative at the time.
Yes. For this particular type of problem. Because in other cases, you could have a condition where you are given the boundaries, for example, type 2 boundary condition. The type 2 boundary condition gives you the slope at the initial and final point, but you don't know where the slope is. Is it positive? So you are given y prime of x0 and y prime of x final, but you don't know the original function. So in that case, your guess will be the original function. So you're just trying your best to meet an initial value problem.
That's your shooting. It was to use shooting for this.
Yes. So the difference is that, so the shooting method suggests that you are given a boundary value problem, but I want to turn it into an initial value problem. So these are known. So what I want to do is to turn this BVP into a IVP, so this will be our guess, and that this known will be our constraint for error. But I don't think shooting method will work with type 3 boundary condition. That will be too complex. But type 2, type 1, and mixed boundary condition should work. How do we find a big guess?
We could just have a certain number, like, and they're both how they raise it up, but they might not have like, they might have more leeway with that, so we can ask, like, we can keep the red. But you raise
You
it to
can't
get
call it, you just print the only solution.
then it will stay the same.
This is not a function. Because you did that's why. So this is the.
Yeah.
If I do thought solution, then it's a function.
Correct.
So can I do the solution?
Yes, for solve AVP, I haven't teached, but yes, you can.
Then this would be a function.
Right. It doesn't print anything. Interesting. I don't think it's working.
I think it's because, we live in like a college area,
Doesn't
so
have a-
people, it's like by semester, so they need like. Next year to like, for people to start.
Okay, not, so you can't really use it.
But my dad says like.
To use that.
Can I do dot y from anything?
Yes.
What would that?
Cause that's normal.
That will be,
But then
that's
it's
a
also
little bit
like,
difficult.
I don't know how
Use
this company
because
works,
the
if, like,
shape
get another renewal offer, cause they can only
won't
not
be
give.
matching.
Cause they don't, I don't know how many apartments they have vacant, but they have like, on their website, it only shows like.
You look at the shape,
Two bedroom apartments vacant, but they're like a lot less than.
then you can also use
Like,
one.
no,
That will not be a function.
By a function.
yeah, it's like
Dot
48
y, then
or, yeah,
this is
48, and then.
So this is saving the array.
So it's my side height in the solution.
Yes. It all depends on.
The first row would be my
Yeah.
initial y0, and then the second row, the first three.
And so here
Period.
you
I also have two rows.
Okay, crazy, like, it's not like a worst case. Yeah,
Just the two.
but I mean, if we don't have to, cause they
or
already give you like a concession, cause like they gave us a small.
in this case, you want to find the error.
Without the concession, so then like,
And so you
now
want to
they're like-
find your second boundary condition. Your second boundary condition.
it's like.
So it's y original function on the right. So I will,
Well, you have to
here, I
negotiate.
find first original function.
Like, you have
That's
to-
zero. In that, on the right, so it's on the right hand. So
Well, you have to, I think you have to negotiate for different like.
that's the.
Like, you're changing. from-
And error like this.
So if we sign that.
Minus y0 right.
I mean, it's not that bad, it's just that
That's the error.
it's only
And
like
the error is.
$41 more a month, but it's still like. But my dad says that you can be negotiable. Because it's also, it's not just. It's more like $60 or. More like $60 more a month because we get like $20 less each session.
This matters. Then in reality, when you implement this, how we going to work for that lesson?
So like for the gas, you will run through the line one time without the one time. You can determine if the error is constant.
Minus 42. Well, right now, in the lease, it says
So
40.
run it twice, but I mean,
So write it once.
And I
without
think I'm just gonna get
taking
it.
out. So after.
Like the best case scenario, we want it to be the same.
and if we get, say, if we get a slope from running once, and then how much the slope will reach that any member that is smaller.
These are trial and errors.
Try and error.
Yes, because these are what we call initial guesses.
Okay.
And for the guesses.
So it was 41, 75.
So you just need
That was a
trial
trial,
and
and we got $100 off, so then in total
error.
that would be 4,700.
Thank you.
Get $1 credits. But then they increased it from the old rent, so now the new base rents are 41. That's what it sounded like that. What we talk about tonight, if you want to do, maybe email or something. I told him, he's like, talk to me about a minute, and I was like, I don't know. We have to see what.
Extra off. Because if we have that extra 100 a month and then they're adding 300, so that's 200 extra, right?
They're not adding 300, they're adding 125. Yeah.
You should compare that to.
Well, worst case scenario, we just pay like $60. But like. But also it's like, these companies, it's because we run by like a big company, it's not like
That's
a.
what I'm saying. We talked about.
Well, if we talk to the people, well, it's like. They're not making like the new rent themselves, like it's a machine, they're using like the AI to calculate what's calculated. So then we just have to see. But I'm gonna work in a comparison. Everything is 40. Yeah. That's including parts. It's parking 107. So they want to raise it to 44 to 75.
Which comes is that?
Gray Star.
Which one?
Gray Star. Still cheaper than living in the dorms.
Yeah, it's like, for 11.15.
But you live with 3 other people and you have 8 friends.
Yeah. And then I realized like people only put 500.
Did they negotiate it? Seems like you're thinking negotiations. He wants to live in your dorm. Do you and your roommate want to live there?
How are we doing on the first practice problem? Finished? Okay, do I need to walk through it? Or we can move on to the next section.
They see what your result looks like.
So it should match your analytic solution. So the purpose of the analytic solution is for you to verify you had done it correctly or not. So common things to check. So these are just analytic solution things that you usually define, is that in this case, the boundary condition is different. The boundary condition is the original function on the right. That's 0. It's not the first derivative. And so when you define the boundary condition, you need to index at 0, meaning the original function, minus the original function on the right. So this is the first place to notice. And the second part is when you're finding the error, you're also using the right boundary condition. And the right boundary condition should be y0, the original function, at the last value, not y1. This is another common problem. And the initial guesses, you can have different numbers than me, but you have to make sure that a negative must give a negative value of the error, and a positive must give a positive value for the error. And other than that, I think those are the most common things that could cause a false answer. What?
You attach your draft like the whiteboard thing you wrote.
Yes. Here, yes. I'll post this too. Okay. So the next part, I guess, will be easier because instead of root finding algorithm, we use fsolve. So it stands for function solving. What it does is it finds the root for some function. For example, I have a function, f is lambda x of x minus 1. This is a linear function. And we know that when x is equal to 1, f of x is 0. So what the function does is that it will find the x at which the function is equal to 0. So it's scipy.optimize fsolve. If you do a question mark, you can see what it needs. So it needs a function. So the function will be the lambda function that we have. And the x0 would be an initial guess. So I'll guess maybe 0. And the result is that it gives us a list at which it thinks f of x is equal to 0. In this case is 1. You can do also more complicated things like square. In this case, it's when is equal to 0. Also x equals to 1. Okay. So I think this gives an error for some reason. So that means our initial guess might need to be updated. So we can update to 1 or 2, and it will give us the correct answer. So again, the caveat for numerical method is that it only gives us one answer. So if I do sine of x, we know that when x is equal to n pi, where n is an integer, it's equal to 0. But if we supply this, say, this to fsolve, it will only give us one answer. And your initial guess will determine which final answer will give. So if you give it something very near pi, it will give you the solution at pi. If you give it a solution that's near pi over 2 pi, it will give you 2 pi, etc. So your initial guess here matters for the fsolve. And so, wow, what is this? And so for this, no, I deleted this. So for this problem, delete these. These are the same. These are the numbers, the points that I defined, the ODE system, I use to define this ODE system, the boundary conditions, and how do we solve the BVP. And we can plot the guesses, plot the solutions. Same dimension. Okay, I should index at 0. So this is the original function. So this is our final result. And now we want to try how to solve it with shooting method with fsolve instead. So in this case, we want to solve for A such that the error between them is 0. So this is our function to solve. So we'll have the error function is equal to 0. So we need to define an error function. It will return the error. And for the error will be equal to the result from the solve IVP with the boundary condition on the right. And the boundary condition on the right here is y1 right. So it will be the result y1 to the last element minus y1 right will be the error. But we will need to find what y1 is. To find y1, we will need to solve IVP. SciPy dot integrate. So I'll do it outside. Dot solve IVP. So instead of solve BVP, we first solve IVP. Give it all the system, the X boundaries, the what else? Initial conditions, and T eval is X. And here the initial condition will be the left boundary, which is y0 left, and our guess A. So for example, if I have A is equal to 1, it should give us the answer. And store this as ODE solution. This will be dot y. And this gives us 2 rows and then 1,000 columns. The first row will be x is y0, and the second row will be y1. And y1, the last element, should match, hopefully, the boundary conditions. So I'll just put these here inside the error function. And because we want to vary A in every iteration, instead of defining here, we'll make it an argument of A. So this will be the error function. And then we can use fsolve, SciPy optimize dot fsolve, and input the error function because we want to make it 0, and then give it some initial guess. Oh, and this error I have figured out before for you is that when the fsolve is supplied with a function, it doesn't input an integer. So if you print A, it inputs a list, but we need an integer here. So what we can do is to A is equal to the first element of A, and this should solve the problem. This is the fsolve function automatically feeds in a list instead of an integer, but we're assuming that A is an integer. You can't have a integer and then a list. So what we're doing is to extract the first element, which is what we need. And then here fsolve gives out a list, so we can index again 0 to get the first element. So this is minus 2.27. And this is the optimum A. And using this optimum A, we can solve this ODE. So instead of using A, we use A optimum. And we can solve it. And then we can plot this X and Y0. and they overlap with each other, meaning that they are the same. So the process for solving using shooting method with fsolve is that you first define an error function. The error function is the solve IVP result minus your boundary condition 2. And you solve your solve IVP problem again and again using fsolve function. And the result of the fsolve function is the optimum A, and you use the optimum A to solve the IVP, which gives you the solution. Any question?
Using optimized fsolve.
Yes. So this line requires 2 arguments. So the error function, which is the function that you want to solve. So what it does that it strives to make this function output to be equal to 0, which is what we want. It wants to make the error 0. And our initial guess is the second argument. And the initial guess is for the A, so the input. So the first argument is a function that we want to make as a 0. And the second argument is the initial guess for arguments of the function. So technically it should be a list because you can have multiple arguments. But in this case, we only have 1 argument. So it will be initially we guess that A is equal to 0. Could also guess 10, doesn't matter.
But isn't A a list like how to see spit out?
Do you mean that if I input a list of 10, how does here become a number?
Yeah, because you said like A is a list, and then your second line is to extract the first element.
Yes.
So with your function, then what it does for the second argument is that a list?
Oh, I see your point. So initially we input an integer, right? It automatically detects and then convert it to the standard form of a list. So it won't double list. So if you look at the documentation for fsolve, it requires that the x0 to be an array, but we didn't input it as an array, so it converted it to an array for us.
So we put in the integer. It creates an array.
Correct.
You have to extract the integer.
Yes. And then there's a practice problem that you can try this yourself. And the results should be consistent with solve BVP.
Why are we putting the bracket 0? How do you say that?
So the result returns a list.
Oh,
Yes.
Oh, I have it. So. And then. How would you do this?
Have one, but my rent would be about 10%. I'll just-
10%?
That's-
Oh, wait, no, 10%.
I'll just pay.
10% under California's 10%.
10%, I'll just pay 12.
Yeah. So you're gonna live with this.
I'll just-
This is 10. Does he only sleep because he has no class? So, is he doing it?
No.
Does he study? Does he have anything he needs to study?
Wait, that already?
Oh my god. He's from SoCal. Yeah. Is he? I don't know that.
No, he's from Santa.
Oh.
He didn't go to gym or he's sleeping.
He just chews and sleep while you're not.
And I constantly wake up at 8, no, actually wake up sometimes at 5, at 8, at 2, every time.
Interesting. Well.
Is he ever so stressed?
Imagine. Not being stressed. You can have a life. What are the other two people? First, you just do. Oh, you're one thing. They. Well,
One guy is off the gym.
he's on
Off the
art.
gym.
He's Japanese from Japan.
Yeah,
He came here for art.
yeah, he focuses on poverty.
Is he rich?
He's super rich.
Oh.
And then
I'd say that was good.
he's a big smoker. He smoked like 10 blunts a day.
Oh, weed?
Yeah.
That's not. There's
He is.
nothing going on with there.
And that day was comment is like some of the rare state our room doesn't smell. And then he's on the crisis right now with his girlfriend and his the situations he's on, but he kind of go back to Japan and drop out of school.
I mean, not like the art thing is gonna do much.
Here.
Yeah, he would tell you something. It's just like, but the art one is like really good actually.
Some of them are not Zoom.
That's actually, that's a whole lot.
Yeah, that's a good. Doesn't take.
They're all good.
How's practice problem?
Sorry, we're stressing over our rent. That's all.
If you're copy and pasting, remember to change your boundary conditions. And when you're calculating within the error function, also change the error.
I mean, it's more work to find a new person, but it's like they could potentially not give you a new thing. Yeah, I mean, like, they're not bad tenants, they're doing. Oh, he missed the one under this. Fix it though. How's the shower?
The shower is good, I think, so I fix this.
Oh,
I think so.
the maintenance. That's nice. That's good. It was not the creepy one.
No.
Okay, good. There's a creepy maintenance guy. He's gross. Okay. Good. She's a physics and neuroscience major. She's pretty good.
I think there's something wrong with the error function, but I cannot figure out what the problem is. This is a practice. Yeah, it's a practice problem. So essentially what I'm putting the software function, right? And first we just set it to I think this should be right. The only system should be right because I'm using for the solve of the BVPs.
Have you done one? I don't
yeah, we linked it to and
I'm gonna try to finish it today, so we have.
and then this should be today. I don't know why out.
My grandpa sent me a picture of like him doing this, and he was like, "Can I call you right now?" And I was like, "I'm gonna call."
Wait.
My grandpa's, he's also can be. I
Possibly can be.
no, he was like, your homework. Yeah. And he's cute little old Asian man, but he was saying that, oh, process engineering is not that hard. Send me your homework. They don't. They definitely don't. My grandpa went to college in Taiwan.
No, like this, like, work, and they like.
My grandpa worked in Illinois
It's insane.
in a nuclear power plant.
So.
He has 2 master's degrees. I asked my grandma who went to Berkeley, who's around 90s, if she's in Vegas.
Oh, like, he's staying in Berkeley, like, it's all like, I got his PhD here.
But he didn't go here anymore.
I mean, not undergraduate, from PhD to now, that's like 50 years, like, the biggest thing.
I would be surprised. It's probably time more.
Where is Wang?
What is Tigger? That's why she is teaching.
So you see middle grasses and going.
Yeah, they shouldn't matter.
Right, we got like, PhD works since back in 2000. And he's not down there, like, like 1996 is a thing, outstanding teacher. Yes, so now.
But now your figure, he just sits with him while they watch Shannon, and then that's not right, Shannon. That's not right, Shannon. Shut up, Shannon. Why are you talking like that, Shannon? But he didn't address it. That's not how you know it's best. No,
He doesn't make me air.
how did they clean out the drain? Did they unscrew it and then they just scoop stuff out, or? Oh, I thought you're not supposed to do that. His building, you know? He has to fix that later.
Oh,
Okay. Yeah, so you did everything right except.
You're like, middle of that. At least they're not raising it too much, like $50-$60 is not like horrible.
It's recently
Yeah.
each. Oh, that's fine.
Okay, how are we on this problem? Did you guys get the final result that's consistent as before? Okay. Do you want debugging?
Can you scroll up to the
So
oh,
it's 9. This is a y0 because it's our original function.
one, zero.
And then in the error function, also y0.
You can just like, mostly just copy it because it's awesome.
Oh, so you move this to the right, it's the minus square.
That's negative.
Because I'm curious, it's not community separate from that.
And then this is the, oh, okay.
We don't have to do.
Huh?
We don't have to do that. 16.
Why are they changing the thing? Okay, no.
What's the name?
Oh, no, right.
Yeah, it's like,
But keep them close to the other she's lost.
These are boundary questions. It learns to.
oh,
It's not the.
67. So, yeah,
So I'm saying, put on the 16, and you're supposed to go to 6 flags.
they haven't changed the definition.
Bro, why are they punching?
Oh, the ender. Alright. Anyway,
It should be y zero left without the.
Oh, I'm just.
It's not so small. These lines shouldn't be indented.
Oh.
It's like this hard coach, he's in Halloween.
Can you take inputs? Arguments or something?
and then you.
What, 6 months?
Like, what did you receive?
I mean, would be system. It's not so.
If it's something.
You have to make it, but.
To ensure conditions.
Yeah, that's fine. Yeah.
Which is like. When. Arrow can use.
No, it's just like. The only one they was.
Pretty sure there's no 6.
Yay!
Yes.
Thank you.
Everything looks good.
What did you text?
Oh.